Ho, 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 ho. Oh my goodness gracious. We have another stream that I need to set up for. Hold on. At everyone, copy, paste, go to Twitch. I'm so sorry. Normally I'd have two monitors for this. We're still waiting on the arm thing. Apparently I ordered one that, shut up. Sorry, my voice is a little bit out of it still. Copy, minimize, paste, send. Okay, today is programming day, but while we're waiting people to join, I have a little story to tell. Okay, that's not maxed out. Okay. Let me tell you something, all right? Fucking God. So I DoorDash my groceries because what is $5 extra if it means not going to the store? Katie, you texted me yesterday. Did I ever text you back? I don't think I did. Sorry, I saw your text, Katie and Corky. I know you guys are on your way to Texas, okay? Had a journey I went on, okay? Hi, hello. I did not. Sorry. Jeez, I'm such a jerk. I'm mean. Also, ignore this. It's my lighting. I only have one light set up right now. I have other lights. It's chaos, all right? Okay, you're in Texas? Yeah, okay. I knew you were on your way, but nice. I'm glad you're enjoying Texas. All right, let me get this story out of the way because I can't keep this out forever. I ordered DoorDash, okay? So I DoorDashed my groceries today because I live further away from home than I did before, right? I ordered a 16-ounce bowls of watermelon I could order for work, right? And I was like, oh, it's perfect. It's like a little lunch snack thing, right? Healthy for you. So I ordered these 3 bowls of like 16 or 17 ounce of watermelon, which is like a perfect size snack. And they're like, substitution made. And I'm like, oh, I don't know. I didn't know you could substitute the watermelon bowls. I didn't know there was an alternative. So I get the substitution. I don't know why I got sent a 5-pound, 3-ounce pack of sliced watermelon. What am I supposed to do with this? What am I supposed to do with 5 pounds of watermelon in one package? How is a man supposed to live? I'm trying to open it so I can have some watermelon. Come on. These packages are like iron. Jesus. You still owe me photos? Oh. Camera's right here. Listen, Corky, you have to understand, it's not easy to get photos off of a camera, okay? You would think it would be easy, but that shit ain't easy. Why is it scotch taped? Oh my God, I just wanted a little watermelon bowl. I just wanted a cute little snack. I am getting like watermelon juice all over my pants and that's upsetting. Okay, there we go. Oh, watermelon, come to daddy. It's so hard to open. Oh my God, am I breaking? I'm breaking it. Oh, I did it. It's open. I have watermelon. Gimme. Hello, Duck. Sorry. I just got sent a 5-pound packet of watermelon, so I'm trying to chew it down a bit before I put it in the fridge. I just wanted a little snack. It's been a while since I watched you last. It has been a while. I haven't streamed in a while. Okay, enough of the 5-pound pack of watermelon. Hold on, this isn't shutting. I have to eat a few more. Corky, Katie, how's Texas? You guys just moved there. How you guys enjoying it? How's the weather? How's the cold? Okay, that's going over there. That's staying over there. That's not shutting. Ew. Okay. It's not cold. It's windy. We should reread Fahrenheit 451. Oh man. Doc, you just referenced content that I haven't touched in maybe 3 years. Wow. Fahrenheit 4, you were there for the Fahrenheit read-along? That's wild. All right, let's get on topic here. It's not as pretty here. Oh, it will be. Wait until springtime. It'll look great. Wow, that's a long time ago. Okay, first of all, we need music, okay? I don't like silent streams. I can't do it. I'm sorry, I can't do it. Hello, me. Still no VTuber setup because my iPad's over there. Okay, we have a lot to talk about. Actually, never mind. Hold on. Okay, if you guys don't know, we have a game that we're going to start from scratch today. Well, not really. There's a lot I've already done. Follow H API is depreciated. Oh my God, I'm so sorry. I didn't know that was depreciated. All right, check back tomorrow. I'll get that renewed. I have a lot of time now. Guys, today, as of like 3 days ago, I finally have time for like everything. So it's beautiful. I have time for it. This is all recorded and almost done being edited. Chat, you have no idea. That's okay, whatever. The video game history project, that's coming later. We're not going to talk about that today, okay? That's a whole journey that I went on for 4 months of my life creatively has been spent on that. But now we're back. We're back and we're ready. All right, if you guys don't know, we are making a Hololive rhythm game from scratch. Now, I say Hololive rhythm game because Hololive has a bunch of songs, music videos, but there's never been a rhythm game made out of it. And I thought, well, hold on. I could do that. I could make a rhythm game. I have the capabilities. It's not online. It's all single player offline. And I know how to do everything. And I've always wanted to play a rhythm. I love rhythm games. So it's like perfect, right? So chat, hear me out. Before we do anything, I want you guys to see something. I know what the failure state of this is gonna be. Okay, you ready for this? Wait. Where's my... Oh, there it is. Okay. This, I want you to imagine this when you fail. Okay, this! You play the rhythm game and you frick up the song. Okay, you screwed up, the song failed. This is what plays. Do you guys even hear that? I hate not having more than one monitor. Hold on. Oh, you guys kind of heard it. Look at this. Look how angry Sora is. It's perfect. God, I hate only one monitor streaming. It's driving me wild. Should I prime sub to you because I don't use Twitch anymore? I mean, hey, I would appreciate whatever. Don't feel obligated. Been a long time follower, Duck. God damn. Wow, you're Prime Gaming. But yeah, that's gonna be what we make. We're gonna program it from scratch right now. That's today. We're not gonna put anything off. Also, if you guys don't know Hololive music, oh my goodness, you're a 5-month subscriber. Oh, thank you, Duck. I appreciate it. Did the sound effect not play or did I not hear it? Oh, never mind. There it goes. Thank you for your Prime sub. I appreciate it. Duck 19872 1982. 1982! Oh my God, it just came back to me. I remember. Did I referenced 1982 or something when I saw your username? That's like in my head. Anyway, yeah, that's awesome. Thank you. I appreciate it. Yeah. If you really want to see good content, I have an entire edited, scripted, beautifully researched, by the way. I've read like 5 1/3 of a book on video game history. I am ready. This is a video game history project. Oh, it's coming soon. Oh man, get excited. But yeah, we're gonna make a Hololive rhythm game right now. So, sorry. Every rhythm game has its own Through the Fire and Flames, right? So what is the Hololive version of Through the Fire and Flames? And the answer is always the same. Not always the same, but Carbonated Love. Fuck. Sorry. That's our Through the Fire and Flames. Well, this is my random popping up today. See you next year. See you later, Duck. I appreciate it. Thank you for the sub. Man, I haven't done that in a while. It's been 4 months. Holy cow. 4 months and I have 5 pounds of watermelon next to me that I still gotta eat later. Oh, that's not even gonna be good for that long. Oh, it's gonna be a disaster. It won't even shut. Okay. Anyway, let's program. But yeah, this is our fail state. I love this. God, I love it. Okay, anyway, let's turn on some lo-fi Leah and let's get programming. Season 5. Let's turn on low quality so that way we can not have issues. Okay, audio is... Let's wait for it to boost in. Give it like 4 more seconds. It's lo-fi music, so it like bounces. There's dynamics. Okay, that's fine. It's a little loud, maybe. I'm gonna lower it just a little. It's gotta be a background noise, not the main draw. I'm lurk while making brownies. Katie, I hope you enjoy good brownies. Okay, anyway, let's program. Let's start. Stop distracting me. Hi, me. Okay. We're gonna start by running up Visual Studio. So, if you guys haven't been seen programming streams before, oh boy. So, I've already started on the basics because it's been a few months. I just had to relearn everything. Currently, we have, if you guys know anything about programming, we are doing, actually, do I need to display this on stream? I probably should. Don't I have like a label for that? No. I swear I had like a, oh, there we go. Music IRL stream. Oh my goodness. This is C++ 23 plus SDL2 homemade, oops. Homebrew engine. What else do I say? Homebrew engine. That's it. We'll just do that. There we go. It's kind of cool, right? Okay. C++ 23, SDL2. Actually, I should say 26. We are using a 26 feature, aren't we? Yeah, we are. We're using, for the, it's a file system function, but we're not gonna do that till later. In any case, C++ 26, beautiful. All right. Now, how does this program work so far? The way it works is we have our auto main. Now, okay, I'm gonna walk you through this. This is from my understanding as much as it is your understanding, because I have learned since we did our last video game stream or video game programming thing, I've learned a lot the last 4 months. I have read up a lot of programming on my own. I learned where I made mistakes because they were not immediately obvious to me. Like the programs would still run. It just looked really ugly, but the foundation was there. The fundamentals were there. I just had bad implementation. It just looked really bad, but it's good soul underneath, okay? So what are we doing? Well, we are using a C-based library called SDL. Now, this import thing does look different than a hashtag header. This is modern C++, so things are gonna look a little bit disgusting. We have our main function here. That's why these arguments are here. It's to account for the, actually, hold on. I don't even like, this works, right? It's gonna pop in and out. Okay, we were testing full screen. So this is our full screen game. Oh, full screen, I don't see anything. I hope you see something. Hold on, what do you guys see? Oh, that's the wrong button, god damn it. Okay, you do see black. Okay, so this black background, this is the game. It's running. So I do want a full screen borderless windowed game. That's what this is. So that works correctly. So now just to be sure, int AC character pointer AV run. It should be the same thing. Okay, sweet. I just think this looks cleaner. Okay, in any case, we have our initialize function. This initializes something called app data. We use auto because this whole trait is huge. Because under initialization, we use a modern C++, this. So Functions in C++, modern C++ work like this. So traditionally it's something like int return, I should say return, find int or something like that. Then you would have your int x parameter, and then you would have your code, right? And that's like a traditional C++ function. Modern C++ is a little different because what you find with these functions that are labeled like this is you may have like a float, yada yada, and then you have the code, and then later you might have like a one of these, and then yada yada, and then function. Now what you're gonna find here is there's kind of a problem. If you're trying to scan through visually to find out the function names, they're all over the place and they're not consistent. So modern C++ has solved this, or not solved it, but it's tried to answer this. Instead of int, find int, what you're gonna do is you're gonna type auto. And then you're gonna type an arrow and say integer. So now, regardless of what you're actually returning, it's the same thing as we had before, except now you have your auto, so visually it's all in the same column going vertically. Then you have your function name, and at the very end tailing, you have an arrow pointing to whatever you're doing. Now, I go a step further personally, where what I do is I have it on the next line. So regardless of what we're doing, what I can see visually is this function is returning this value. This function is returning this value. And as an example, this is our initialization function. So it's the same thing. It's that auto right there. And that arrow is pointing to what we're returning, which is a standard expected app settings. And on error, return a string. That's what this phrase means, which is a modern C++ feature. It's expensive resource-wise, but that's why we only use it for initialization. So, sweet, right? Pretty cool. Let me check something. Okay, sweet. So, this is our initialization function. We do init everything because I'm lazy and SDL3 doesn't feature this, so we just initialize everything. You should do like, SDL initial or init audio, SDL init video, and do a step-by-step and then debug it if there's any issues so you know specifically what's failing. I just init everything. It's bad practice and it's not that hard to fix, but for my sake, for right now, it's fine. It's totally acceptable. There's no issues with it right now. But we make the window, point it to a null pointer. We make a renderer, point it to a null pointer. We make a display mode and then immediately get the current display mode to give it a value. We change the resolution of the screen to be a rectangle. So this rectangle, this SDL rect, it's just 0, 0 is the X and Y value. We set the height. Well, sorry, let me be specific. Because this is a borderless full screen game, I just set the height of the game to be the height of your monitor. That's what this DM means. This current display mode, it grabs your primary monitor, which is 1. If you have more than one monitor, you know how it's like 1, 2, 3 on your change monitor settings so you can decide how they interact with each other. It just grabs 1 and it plays it on there, I believe. It could also be your active window. I actually don't know. But in any case, it grabs the height of that monitor that you're going to play it on, and then the width is the height of the monitor times 16:9. Now, that's not arbitrary. This is basically spelling out a 1080p resolution. So if you have a monitor height of 1080p, and then, your monitor height of 1080p, the width would be 1920. So we can prove that right now mathematically. So 16 divided by 9 times 1080 is 1920. So 1920 by 1080. So when I press play, it's a black box that is 1920 by 1080. Keep in mind, by the way, we're gonna have to change this X value because right now it's 1920 by 1080. But if you have a monitor like mine that's super ultra wide, the game is going to appear on the far left, which I guess this is right for you, but whatever, on the far left of the monitor and only stop like 2/3 of the way. The rest will be black, which is incorrect, which is why we're keeping this value as 0 for now on the X, but we can change it later. Gary the boy, JRR. Oh my goodness, long time no see. How's it been, man? Oh, I hope you're doing well. It's been a hot minute for me. I still gotta set up my second monitor, and I have 5 pounds of watermelon next to me that need eaten. But we're doing all right. Oh man, I'm happy. We finally get to program this game. Anyway, we continue our initialization function. This is all work I did off stream, by the way. So we set up the if statement, but this is calling the function to create the window and the renderer. So we grab that width and height of the resolution rectangle we just made. So that those are these values. Then the SDL full screen desktop. This is a flag we're putting in. It's an enumerated flag. So if we wanted, say, a windowed version of an application, or if we wanted full screen where your mouse is not locked to the monitor, this is full screen, your mouse is locked to the game, which is, you know, in a rhythm game, kind of ideal that uses the mouse. So that's why we're doing that, but that's where we would change it. Then we grab the window, then we grab the renderer. These are by reference, so we're grabbing these because these are pointers in the C-based library of SDL. These are pointers to window and renderer objects, so we grab these by reference here. And we create the window and renderer. So now whenever we reference L window, L renderer, we are going to be using these things. So we're going to use the renderer to do things. We're going to use the window to do things, render objects and all that stuff. That's how we create these. If this fails, we return an unexpected failed to create application. And because it's an unexpected, the program will just crash. Same thing here. If this fails to create a window, failed to create window. If this fails to create a renderer, failed to create renderer. If this fails to create TTF, failed to initialize TTF. Yes, because we're initializing TTF here. TTF, by the way, is true type font. So that's how we display numbers and text in the game. We use fonts. That's how we do it. Sweet. Excellent. I'm doing better. Just got my teeth pulled last Friday. Oh my goodness. Last Friday. Hot damn. Wisdom teeth, I hope. So anyway, we go back to our main value here. So now this app data is the expected value of app settings. So all of our window, our renderer, everything here, this entire struct is this. So I should make this const, shouldn't I? Can I make this const? Okay, sweet. I want that to stay const, which means this should be const. Okay, good. I want resolution to stay const because we're not going to change the resolution, hopefully. Anyway, if this doesn't work, so if app data returns as the string, the error string, instead of the app setting struct we just made, then it's going to print line. Print line is a modern C++ feature. It's like the old C-based print line issue. It's almost exactly like C-based print outing. So it's standard print line, parentheses, what you're printing. And in this case, it's this error. So app data, the expected value, the standard expected, has in it a way to access the error via .error function call. So this is an object, app data call error, print this. That's what these little squigglies mean. So if there's an issue, it'll print the error, it'll crash the program. If it continues, then we're gonna call the game loop, sending the app data as a value. The game loop is the standard expected and a string application. So that is the referenced value. Gosh, how do I say this? This is what we're calling as a parameter to the program. Even though it's standard expected, the only time it should ever actually get here is if it's a working case, but we have to call the whole object. We pass it by reference, so that way it's just the pointed value, not the entire rendering object. And we just call it app. So anytime we reference app, it's accessing the information like the screen resolution or the renderer via a pointer. So that's kind of where we are right now. The rest of this is just the start of the game, and that's it. We're caught up. This is HoloRhythm. This is going to be what is going to become a Hololive rhythm game, which is pretty sweet. So what are we doing here? We have a couple of uint32s. Uint32s are 4-byte integers, which are very, very, very large. The reason why is because we're keeping delta time animation timer. Why do I call this anim timer? So we have our current ticks, which is a uint64, which is a very large number. And then we have an event queue. So while the game is running, that's what this Boolean exclamation point quit. It means while the game isn't quitting. So while the game is running, run this loop. And this is our game loop. Current ticks is our giant number, is going to be equal to SDL get ticks 64. So SDL get ticks returns a uint 64, which is a very large number, and it just counts as many units of time has passed since the beginning of whatever. So it's based on your computer time. There's a better way to do this with standard chrono. I probably should do it. I don't need SDL to keep time, and standard chrono is so cool. I kind of just want to do that, but we'll keep this for now. In any case, we have timer, meaning this value that's currently 0 because of these squigglies, plus equals delta time, which is 0. So what's happening on the first frame? So current ticks is getting whatever the SDL get ticks gets. So 1,000, 20,000, it doesn't matter. Then this value is 0, add itself plus 0, so it's still 0. And then we have our animation timer plus equals delta time. So we're just going to delete that because we don't have animations yet. Sorry, the other game I copied paste this from had animations, the same thing, as in the other game we made. So, boop, 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 boop. Sadly, no, bad cavities in the, sorry, I don't have a second monitor, like look at chat. Bad cavities in the back 2 teeth, terrible toothaches. The toothaches got so bad that I wouldn't allow me to sleep some days. Oh, that's disgustingly painful. Sorry, I don't mean like it's gross. I mean like I can't even like think about it. Oh man, I love taking care of my teeth. I like having pearly whites. I did have a great holiday season, thank you. So we have our SDL poll event queue. Now what this is okay, let me draw something real quick. That is so bright. Okay, so what is the SDL queue? I've drawn this picture a lot, but bear with me here. So the SDL queue is like a bucket of water with a hole on the bottom, okay? So every time we do something in the game, within the scope of the game, anytime we move the mouse, anytime we press a key, anytime we do anything that is registered as an input, press a button on the controller, registered as an input, the SDL poll event queue fills. So we fill the bucket with some sort of input, right? Now, the way it works is it is first in, first out. So if we press the space bar, press the mouse, press the letter P, in that order, that's the space bar, that's the click, that's the P, and the letter P. And what's going to happen is as the queue, the poll event queue goes down the list, it'll slowly empty the bucket. So the space bar will be registered first, then the click, then the letter P. That is really important, especially in a rhythm game, where we can manage input very cleanly. So what this is saying is while that event queue, while the bucket has water in it, i.e. it's not 0, then do something in the loop. Now, what this means is that because every frame in the game is, we're gonna operate at ideally 60 frames a second, but the YouTube videos are that we're gonna have the music video. The music videos Hololive has are almost always 30 FPS, sometimes 60. So I'm hoping we can get as many 60 rips as we can. But we have a 60 FPS game, which means we have, let's do this here, 1,000 milliseconds in a second, and we're gonna divide that by 60 because we want 60 frames a second. We have 16.66, repeating of course, milliseconds per frame to get the entire game logic done, render done, input done, the entire game. That's like the programming challenge, right? So we have a little less than 17 milliseconds. So if we filled up this poll event queue with 20 inputs, it must go through the entire poll event queue before the frame ends. Now, this is the weakness with our current setup. It might be a little bit worrisome because what happens if somebody panics and they just mash their keyboard with as many inputs as they can? Can the game chew through 200 inputs before the frame ends? I don't know. We're going to have to see. Hopefully. You're live? Code Toil, yes I am. Thank you for subscribing. Why didn't I hear the alert on that? 11 months. Thank you. I appreciate it. It might have been because we heard it a few days ago, but in any case, I do appreciate it. Thank you. Aw, so nice of you. Oh, I hope you're doing well, Koto. Did I like mute this or something? Hold on, speakers. What's my mixer? No, OBS is there, look at that. I don't know. You would think I would hear that more than anything else, but okay. Yes, I am live right now. So we have to go through the whole poll event queue. So right now, I have a few things going, but I would take it with a grain of salt. Right now we have if the event type here. So we have to, it takes in any, remember we're filling the bucket. It takes in any input, but we still have to tell it what to do with that input. So if this input type is SDL quit, and what that means is if we press the X button in the application, what does that do? We define that as quit equals true, meaning the loop stops. It'll proceed to the end of the frame, whatever that frame is. Quit is true. It'll do, the game is stopped, right? The application ends in this case. So that's what that is defined as. So if the event type is SDL mouse button down, meaning I click down on the left mouse button or your primary mouse button. I guess if you're left-handed, it would be your index finger. But in any case, most people, right-hand index finger button down, quit equals true. So same thing, the game just crashes. So if we run it, the game is running, the game is running, the game is running. I will click on, fuck, sorry, I pressed the wrong button, sorry. Okay, the game is running, the game is running. I'm gonna click and there we go, the game crashes. Beautiful. Crashes in, with style. So beautiful, it's working. Moosh! Sorry, it's hard to stream with only one monitor. I'm not used to this. Moosh, how are you? You guys like my bad hair day? I have a terrible hair day today, I'm sorry. It looks nice for the show, but man, geez. Moosh, are you ready for the best content you've ever seen? I haven't been streaming for 4 months for nothing, okay? This shit is jazzed, all right? I am ready. Bonjour, Tassin Khan. Tassin Khan, long time no see. How are you? Sorry, again, one monitor here. I have to like minimize and like go back to programming. It's really hard. Actually, maybe I can be clever about this. Let's put chat like over here. Maybe we do something like this. Oh, I'm big bringing it. Oh yeah, chat. Now we're talking. In fact, if I really want to big brain this, I'll do this. Because sometimes Twitch messages get missed. Boom! Oh, I am the streaming master. Oh, geez. Stop me. Oh, man, I can see you guys now. It's so weird. In any case, let's get back to programming. So, what happened to your other monitor? It is... You know what? I feel like standing. You guys like my standing desk? Okay, in any case. Here's my other monitor. It's still under production, okay? I just moved and this was a priority. So I just moved and this was the priority. So the video game history project comes first. And yeah, also, do you guys like how fat my shirt makes me look? I look really fat in this shirt. Cause like I have like neck fat right now that I need to like lose and it like makes it look worse. But yeah, we have a standing desk and everything. It's beautiful. In any case, that's better. Hell yeah. My 3DS games arrived today. Oh, congratulations. 3DS, you little video game collector, you. Gary the Move Boy. Yeah, Gary the done moving boy. This is 5 pounds of watermelon. I don't know if you guys were here for this story. I tried getting 3 small bowls of watermelon for work for like lunch, and they substituted it with a 5 pound. I'm not kidding, it's 5 pounds. Do I still have the sticker? It's somewhere. It's 5 pounds of watermelon. I don't know. Fucking DoorDash. 5 pounds of watermelon. Can you believe that? All right, in any case. So we're filling up the bucket with inputs, right? That's what this SDL poll event is for. We fill up the buckets with inputs, and again, keep in mind, we're making a rhythm game for Hololive, right? So as the person is pressing the keys, we have to be super careful about input, because again, this poll event queue will process every input you give the game on that frame, and it must be complete before you break out of this loop so you can repeat the game loop, right? So it can go back to like running the game, which means you might get lag. In the same way, the way we're setting up our game right now, it operates like Mega Man X, if you've ever played that game, where, remember how when you're in the minecart section shooting down the birds, it's like kind of chugging along, where you can play the game and it still runs, but it's kind of chunky. That is... Wait, is that what we're doing? I think that's what we're doing. It might not be. That might be the opposite of what we're doing. But in any case, we have to keep an eye on that. We have to, when we test our game, the rhythm game, the first thing I'm gonna do is mash my whole keyboard so it takes all of the inputs, and I wanna see if it lags. Should we talk about the design? Probably when we get to the actual game. Now, keys work a little bit different in input-wise here than mouse button down. Because there are so many keys, we have to use a couple of switches. So the first switch is the e.type. So the event queue, that bucket, we basically define what type of input is going on, and in this case, SDL key down, meaning of all the things that happened in the event queue, like a controller being pressed or whatever, in this case, it's a keyboard and you press down on a key. That is all you're separating here. Then you have another switch case, which is event.key.keysim.sim. This is saying, okay, you press down a key, you have a traditional keyboard, what happens? Well, in this case, we press down the space bar and then quit equals true, and then we break out of the switch cases. So if we run it, we press space, game quits. Beautiful, beautiful. The holidays can make people more plump. Hey, you little shit. I'm not plump. I'm Gary, all right? Jeez. Did I tell you guys Amelia Watson left Hololive? The person who inspired me to get into VTubing? I don't know why I'm crouching down like you guys can't see me. I can stand perfectly straight. My fucking favorite VTuber, Amelia fucking Watson, left Hololive. Can you believe that? That's wild. So we break out of this case and that's it. It's beautiful. I think I only need one break here, right? Do I need a second break? No. In fact, this break should be here. That would make more sense. Okay, beautiful. She retired, she graduated, and she's now goes by Doobie on Twitch. After she left Hololive, she actually talked about her professional experience that she could not talk about when she worked for Hololive. She is actually an Emmy award-winning Foley artist for the Wizard of Oz cartoon, and she worked on like a Marvel cartoon. She worked on a lot, and wow, I'm glad I could spot quality when I watched her. Fucking an Emmy award winner, huh? All right, in any case, let's actually make the game. So what are we doing here? Well, we need to do a lot. So we have the input, we have everything. Right now, there's really not much going on, so I'd like to draw a white box. Let's just do that. Let's draw a white box. Also, we need to handle time and delta time, to be fair. So, what are we doing? Let me recall the process here, because it's been a while. So, SDL, we call a function that is based on update window texture, update texture. Okay, so this is where we're going to recall one of an earlier project we did, just because it's been so many months. So let's check out our card game here. Let's jump to the end. Let's just copy this. Okay, thank you. Let's copy this delta time thing that we didn't finish doing. That's how we keep time. And then come back here. Where do we render present? That's what it was. And then render clear, the global renderer. Okay, sweet. So this is going to look incorrect. SDL, render clear, using app.renderer. Oh, renderer. Okay, we'll come back to that in a second. All right, beautiful. That's what I needed. That's what I needed to see. Frame rate ticks, current ticks, beautiful. Okay. Yeah, she's a Foley artist, right? Okay, so what are we doing here? What did I just copy paste from the other game? Well, basically it's a lot of the groundwork to like do a very basic thing. So what do we want to talk about first? How we maintain frame rate or how we render? Let's talk about rendering. So let's do this step by step. This is the main while loop. And if you guys don't know, when you hear 60 frames per second, what it's saying is every second, this loop runs 60 times. So this entire loop is our video game. We are going to maintain a steady 60 FPS, meaning every frame is a little less than 17 milliseconds, but we'll talk about that in a second. What are we doing every single frame of the game? Well, here's what we're going to do at the most basic level, okay? We are going to clear the screen. That's what render clear does on SDL, right? We're just going to take the screen using the renderer in our initialization module. We're going to take our renderer. We're going to wipe the entire screen. It is now blank. Okay, that's all it is. It is now empty. It's null. It's not black. It's null. Very, very important difference. Then we set the render draw color of, sorry, this is going to be named differently in this application, pointer, renderer. Then we take our renderer and we set the render draw color. In this case, it's 255, 255, 255, 255. This is RGBA. What does that do? Well, what we're gonna do is when we clear and when we render present, as we'll talk about in a second, the screen is gonna be a certain color. Right now it's, well, there was no color before, it was null, but now we're setting it to draw a color instead of drawing null. And in this case, max value RGB is white and 255 is 0 alpha, so it's not see-through at all. So ideally, whenever we render the game, if nothing else appears in the game, if nothing else is being rendered on top of it, whether it's UI or the game or whatever, if I goofed somewhere, then you will see the color white. We should make that like a bright pink or purple or something, so it's like visually catching, but whatever, we can do that later. That's fine. This is just a setup for debugging later mainly. And then we render present. So what is render present? Render present is the very, I think it might be the very last thing we do on every frame. We take all the information, whether it's enemies spawning or a graphic got moved or a sound file is playing or a sound effect goes off or an input is registered or whatever, right? All of the logic of the game is done. Everything is where it needs to be. Now we need to draw it. That is render present. It is the final ish rendering step in the frame, and we have to do this once every 17 milliseconds. This does take a chunky bit of time depending on what you're rendering on screen. If you know what you're doing, it's not that bad in a 2D game. You can have upwards of 10, 15, 20,000 objects being rendered that are clones of each other if you have a good enough CPU. So it's not like it's an impossibility. We made a bullet hell game. It's totally fine. That's what's going on. So if we comment this out real quick, I always forget which order. Comment star, and then star comment. I need that on a shortcut. And then we render, and you should see the color white. Perfect. Look at that. It goes as planned. Now we have a game with the color white in the background on a full screen where the mouse is captured completely. I can't break out of it, which is great because we're doing a mouse-based rhythm game. Excellent. Now, what we're doing so far, it may come across as like duh, right? Like, what's there to be proud of? This is easy. I can do this in Unity in like 2 seconds. It's important that we be super careful here, because if we fuck up, there's no easy way out of it. And initialization is something that you have to be really heavy on the debugging on. That's why we have so many fail states here. Because think about it this way, chat. If somebody installs the game, it's going to go on Steam ideally, because other Hololive games are, and they don't have an issue with it as long as it's free, which it will be. When people install the game on Steam, what happens if one of the files in your game, like an SDL, like what do we have here? SDL header. What happens if they delete the SDL header library? How do they play the game? Because when you, spoiler alert, when you install a game, you are compiling the code on your computer. This compile and run here, that's exactly what you're doing on your computer when you install it, like off Steam and stuff, right? So if they delete it, well, what do? That's why you have your initialization here, and it can be like, oh, failed to initialize SDL and crash the program. Otherwise you have unintended behavior. All that is to say, that's why we're careful about how we start here. That's why we're super methodical. No, that's what they do. No, that's not what they do. Wait, not what? Also, what color are you recommending? Is this the bright purple? Oh God, yes, that's what I need. Perfect, thank you. This is the this is the you fucked up color. If you see this color, this is also blinding to my eyes. If you see this color, something's wrong. So good, thank you. We'll keep this color. Oh God, that hurts my eyes. It's like my whole vision was that. You don't send the project file, you send the .exe. Yeah. Executable, shmezmutable. All right, let's talk about delta time. Right now in the game, that purple box you just saw, we are running at about, what can you do on a 4090 and a 14900K? I'm gonna say 5 million frames a second. There was no cap on it. So that program was taxing my CPU as much as it could possibly tax a CPU. We're talking thousands and thousands and thousands of frames a second, just as much as the CPU could run. It's how you catch computers on fire if you're a dumbass, right? Not that it would ever actually happen, but bear with me. So we have delta time. Basically, what we're gonna do is this, in this order. Remember how at the beginning of the frame, we got the current ticks, we updated the timer and delta time and all that stupid stuff, right? The reason why we did that is because now we're gonna do something cool. So delta time is now equal to the get ticks value. It's that same function we had before, except not 64 for some reason. Huh. I wonder why that's get ticks 64 here and get ticks here. Uh-oh. In any case, we get the current amount of ticks. Then we subtract current ticks. What does that mean? Remember, at the beginning of the frame, we have timer. This value here is plus equals delta time. Delta time is going to be, hold on, wait, what am I doing here? If frame rate ticks is equal to delta time, we don't have frame rate ticks here. This is current ticks. if current ticks is greater than delta time, current ticks is minus delta time. Does this work? Yes. Hold on. Now let me think through this. Oh God, my game crashed. No, in a bad way. Interesting. It didn't quit. Do I need a second break statement here? Code Toil, you know programming. Do I need a second break here? Also, Katie. I hope you enjoy Texas. I think I do need a second break here, right? So it would be this break. It would be here, right? I think it is. Oh no, it would look like this, right? God, I don't remember. It's been a while. So why doesn't this crash? It doesn't, because I'm locked in a loop. So that tells me I fucked up somewhere and we're stuck in like a loop forever. The EXE and whatever DLLs are needed. Most people don't have the necessary tools to compile games, say for instance Visual Studio. Okay, I see. So what do we have going here? Let's just talk through our own logic here. So this should be getTick64 before anything else. Okay, so delta time is now equal to getTick64 minus current ticks. So whatever the frame we started at, whatever that unit is, it can be 1,000 units. Then it's going to run the entire program. And then we're going to grab that starting value again, that getTick64, and then subtract where we started. So we're finding the difference. Given 1,000 units of time at the beginning of the frame, and we set that value, then we grab the value again and subtract those units of time that we started with. So we could end up with 5 or 7 or 10 or 50, whatever. We're making delta time equal to this value. That's important because what we're trying to do is if we are too fast, if our computers are too fast, we, instead of rendering at 17 frames or 17 milliseconds per frame, we render it in like 3 milliseconds. Well, we're going to delay. If the current tick amount, which is this guy here, is greater than delta time, is that ever going to happen? Is this ever possible? So if we start with 1,000, and then this is 1,010, this equals 10. This is 1,000. Oh, I'm stuck in a delay loop. This is bad. I did this wrong. That's why the program isn't actually quitting like it should be, because it's stuck in a delay, waiting forever. Okay, gotcha. So it's waiting like 10 seconds or something. You ask the average gamer to compile the game, they would just not play it. Yeah, true. It's like me getting to work on a CMake file. All right, so we need to fix this. This is not current ticks. Is this timer? Timer plus equals delta time. No, timer is something else entirely. This is wrong. Okay, so current ticks is equal to that. Delta time is equal to this minus current ticks. So now this is done. So this should be a uint64 now. Okay, so where did I screw up? Is it delta time is greater than current ticks? No, delta time is always the one that should be less than the other thing, right? What did I do in my other game? What did I do wrong? Why is it always delta time that fucks me up? Always, just without fail. So what did I do here? Hold on, where's my game loop? Okay, end time, chrono, steady clock now. Never mind, we're okay, we're doing this. Jesus. Why did I even bother using SDL when I can just do what I've already done with chrono? God damn it. Okay, that's fine. Forget everything I just said. We'll go over it in a second. So fuck all this. Oh, beautiful. Oh man. Look at this beautiful C++. Oh, we're sleeping threads? Oh, get in here. And then this is steady clock now. Let's copy paste all this. Man, why solve the wheel when you can just make things better? All right, get rid of this. Paste. So I'm guessing at the beginning of the frame, we get the tick. Yep, start time is equal to that. Okay, this makes more sense. Okay, this makes more sense to me. This is more what I expect. So instead of current ticks, we get chrono steady clock now. Oh man, that took a while. All right, let me explain what we did here. So instead of using SDL C-based fucking shitty uint64, we're gonna do something better. We're gonna use chrono. What is chrono? Standard chrono. Beautiful, right? Standard chrono might be the most powerful C++ library out there. It's incredible. It can do so many cool things, and we're gonna do such a thing now. So we're gonna have a few values here. We're gonna have an auto start time, auto being whatever this value produces. I'm so glad IntelliSense is still fucking up modules after all these months. Save. So then we have current time, steady clock now, physics check, steady clock now. We can get rid of that. So what are we doing here? Okay, Jesus, how do I describe this? We have three values here: start time, current time, end time. Super basic, right? Everything follows the chrono steady clock, which is referencing your, I think, operating system for the time, right? At the beginning of the frame, we set start time to the current clock amount. Then at the end of the frame, we set end time, which is this clock, is equal to the current clock right now. So it's the same thing. We're getting the time at the beginning of the frame. We're getting the time at the end of the frame. And then if this end time is less than the start time of our frame rate, so start time being this value plus 17 milliseconds, which is 1000 divided by 60. That's our target frame rate. Whatever 60 is, in fact, we should not have magic numbers here. Whatever 60 is, that is our target frame rate. So this thread, sleep for this value minus end time. So at the end of the frame, we take this thread, meaning our core on the CPU. We're sleeping the program. We're saying stop the game or stop doing anything for whatever time you need to make 60 frames a second, in this case 17 milliseconds. So we take our start time. In other words, if the game isn't lagging, wait. That's the point of this, right? So let me just think something real quick. Why do we have current time? Oh, we have current time for logic. Okay, that's fine. We'll just keep it there. So we should run it and it should work. Okay, there's our error screen. We click. Beautiful. Excellent. Works as intended. Now we're gonna fix a few things here. I don't like having this magic number system, so let's do a few type defs. So type def. Wait, there was a cleaner way to type def, right? Was there a cleaner way to type define in C++ 23? I don't think so. In any case, we're gonna type def. Actually, no, now I, what did we do before? It was cool. Stop. Okay, it was Wafshire. Wafshire has like the most modern thing we did. Export auto, components. Wow, I did not do a single type def? Oh shit, man, good programming, Carrie. If you ask the average gamer to compile a game, they wouldn't play it. Yeah. All right, let's type def 1000 divided by 60 is equal to expected and identifier. Wait, can I not type def numbers? Or do I have to quote? No, that won't matter. Oh my God, it's been so many months. How the fuck do I not? I don't type def enough. The fact that I don't remember the basic syntax. Type def, current name, new name. I can't type def numbers, can I? What's a clean way to do that? So I can like type def int or like standard vector int as test, right? And then now whenever I reference test, it is a vector int. Okay, that's all fine. But I can't do magic numbers, huh? Type defs are for types. Yeah. Type defines. How do I, am I dumb? Why, wait, what is the, it's not type define. How do I define like magic numbers like 1000 divided by 60? I guess I could just make a value, but I wanted the whole phrase. Because I could just be like, you know, const int target frame rate equals 60. And that'd be fine. And I could just be like, you know, target frame rate. I guess I could just say second or something like that. I could just replace this whole phrase, couldn't I? What about that? Can I replace that phrase? And this is target frame rate. Can I do that? Yes, I can. Oh, shit. Okay, that works, right? No! No matching overloaded function found. Also, didn't used to hate type def, you preferred using? Oh! Is that what it was? Oh, that might be based. Oh. Expecting declaration. Yeah, it doesn't work, does it? It's just so ugly. I think we just have to do that. It's so ugly, though. I thought... Oh, whatever. It's fine. It's just I don't like having the thousands there, you know? I tell you what I could do. Nah, we don't use it enough. It's fine. Like constant value 3 outside of the function. Yeah, it looks ugly. It's fine. We'll just stick the target frame rate here. Okay, there we go. That's beautiful. That's our start of our beautiful little program. Now, we have our frame rate set. We have our render system set up. We are ready to just make the game now, I think, right? We have a way to quit. We have a target frame rate. So what are we doing? Well, we are doing, you could do hashtag define value 3. Yeah, but that looks kind of ugly. Hashtag defines are like C-based stuff, right? Let's see if that works, I guess. Get rid of that, put 60. Oh. Define that as a target frame rate. Doesn't work either, huh? Whatever, it's fine. We'll deal with this for now. It just looks ugly. In any any case, you know what we should do is set up this as part of this, huh? So we'll have const int target frame rate. That's where we should put it. Also, can I not do this? Wait a second. This should be like this. What am I doing? Yeah, let's do that. Let's just set up an int here. Frame rate. And then part of the struct will take in the target frame rate. And then that'll go in as a const. And then we call it here. So it'd be app pointing to, app pointing to, and that should just work. God, I'm so glad I know what I'm doing. Oh man, I'm good at programming. Their preprocessor definitions, yeah, it's fine. This is fine. It looks cleaner. It's defined. It is kind of nice that in our initialization, you can just change things like the resolution and all that stuff. It feels like it's appropriate for the frame rate to be here. See that big of a deal there. In any case, let's continue. I think it's time we focus on ECS. Do we start with an entity factory? Or do we start with components? What's more important to start with? Do we have time? We don't really have time for a full entity factory right now, so I think we just work on components. So new project, add module. We're gonna call this components. Now this is gonna work differently than how it worked before. This is a module. Let me make sure I get my syntax right. Export module components. We are going to import the standard library. Whoops, not that. A standard library. We are going to import. Do we need SDL for this? Yes. Import the SDL. Do we need SDL image or anything? Yes, because components can have graphical or audio capabilities. So SDL dot image, SDL dot SDL what? Okay, we need the TTF header, that's for sure. Oh, I know what I did. Import SDL underscore image dot header. There we go. So let's just run it. This should just work. Okay, beautiful. No issues with importing. TTF is true type font. So we import the SDL header, the SDL image header, the TTF header. We're gonna also import audio stuff, but we're not gonna do that now. Oh God, we gotta fucking do fonts too. Ugh. All right, so we're gonna call a function here. No, let's construct. Let's make a class. Class is structs. I should call these structs, but we're gonna have more. These are gonna have private values, so I think it is appropriate to call it class. Let's call this position. And what we're gonna do, what is in this position? Well, we're gonna have a private, oops, private. I like having public before private in classes, sue me. Now, why are we making, actually I should call this component position. I'll just call it position. This is a component. Now, do I need to explain what an entity component system game engine is? Basically, gone are the days where object-oriented programming was king. Back when you had like a class hero, private value hit points, public value change hit points, like current HP, function happens if you die. Gone are those days. Nobody really does that anymore, but besides like if you're learning programming, now everyone does ECS correctly. The point of ECS is like for many reasons. One, encapsulation. Two, systems being completely decoupled from the entity system, and which is sort of decoupled from the component system. What that means is that systems can be easily divided into different cores. It can be multi-threaded significantly easier than a non-ECS engine. We are probably going to have to do that, but we're gonna cross that bridge when we come to it. In any case, we're gonna make a component. Now, if you've seen previous games we've made before I was like this, struct, position, and this has an int x and an int y, and then we called it a day. I have since gotten much wiser about programming, okay? Here's the problem with this. Later on, we're gonna give this position value to an object, and it's gonna be enemy x is plus equals to enemy x plus equals like 4 or whatever, right? And that's how we would change it. Here's the problem with that. The moment we use it, it becomes more and more difficult to change this if we ever wanted to for whatever reason, right? Here's, I think, is a better way to do it. Make it a class indicating it has private values. Then you have stuff like, you know, const get value x, and it would just be that, right? And then boom, return x, and then we would have int x, something like that. Oh, const int get value x. So that's how you would do it. And then you would have like void set value x int x is equal to new value, x is equal to value. Beautiful, right? Oh my God, so clean. What this does is this allows you to get and set values without ever touching the original position, so we can change the logic here and everything else gets affected. It's beautiful. I love it. So we're gonna do the same thing here, but we're gonna set value to y. And then we're gonna do the same thing here, set value y. Okay, now, what this means is that later, when this component gets given to a entity of enemy, it can be enemy dot set value x, and then we set the value to enemy dot get value x plus equals the value of plus value x plus equals 4. So this is the same thing we did before, but this is so much better, because if we ever wanted to change this, I'm not saying it's easy, but we would have to change these functions and values here. And then as long as the function calls get changed the same, everything else works too. So this is kind of what we're gonna do for pretty much all of it. Now, the real question is this actually what we wanna make a component of? I think position is too specific. I kind of want, maybe, I'm trying to think about how we want to do this, because it's a rhythm game, right? A position is extremely important. But do we want like stuff like width and height involved? Because is something ever gonna have a position that doesn't also have a width and height to render? Yes. The font. Because fonts are already, well, ideally, pre-rendered, meaning that you just grab a snippet out of a TrueType font file that is the appropriate rendered object and you clone it next to each other to give the appearance of like words being typed, right, or written. That would not need a width or a height on its component because it would just use the X and Y value. It could be just be 0, but whatevs. So I think that's fine. So we have our position component, right? And then we have, what are some other things we need just to get like fonts on the screen or like UI elements? We're gonna need a render box. We're gonna need a draw box. We're gonna need a, well, I guess it is a render box. There's no hitboxes in the game, is there? Yes, actually there will be. Let's do a render box and then we're gonna do a hitbox, collision box because that matters. We're gonna use it. So same thing as before, the render box will be an SDL frect, that's what we did, right? SDL frect, and this frect is going to be render rect. Now, we don't grab the value here. This is this ever gonna be const? No, these aren't const. Getting the values will be const. So const, these are float values, right? So it'd be const float get value X return render rect dot X. Do we want to do this or do we just grab the whole frect? I would rather do that. Well, because there's going to be a lot of situations where we're going to need like the XY width height of a render rectangle. I'm trying to think of what I would rather do. Would I rather call this function like get value 4 times? So it would look something like enemy dot what would this be? Render box dot, no, it would be arrow. Render box dot get value dot X. That's what it would look like, right? It looks kind of ugly. And then it would be like comma Y, comma width, comma height, and that would just be copy pasted 4 times. Otherwise, it's get value X and then width and then height and whatever. I feel like I'd rather just have get value. I think that's the way to do it. And then we return the whole render rect. I don't know how else we would do that cleanly. The setting value needs to be independent though, doesn't it? So it would be void SDL, no. If we set a value, like if we play a rhythm game, am I ever going to be manipulating the width and height of a render rectangle? It must be possible, right? Vulcan, 7 years old. Oh, Vulcan. Listen, all right. We already built a triangle in OpenGL, and now I know how to do that in my head, okay? Vulcan might be opening a can of worms I don't know if I'm ready for. Identifier render rect is undefined. Why? How? Oh, because of this. Okay, so we have void set value. What am I gonna want here? I could just send the whole frect. If I'm gonna change the render box, like let's say we play the rhythm game and we want to change the size of the button, or the thing that's on screen, so we can have different size circles, right? Like Osu, if they had different size circles. They don't, but if we did, it would be just be changing the width and height of that No, we do need to set the whole thing. Because fuck me, every frame, we are moving an object's render rectangle. Okay, so we do need to set it a lot. Okay. Oh shit. This does need to be float values independently. So set value X, float value, and then that is just going to set render rect.x equal to value. And there we go. And that's the whole function. And then paste, 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 paste your booty. Music. Let's do Zelda mix. It's the hype, right? Oops. So now we have a value. This is going to be .y. Set value width, .width. Set value height, .height. And if we ever need to grab it, we can just get the whole value. So what does this do for us? Well, now we can go enemy, render box, actually it should be render rect, dot, set value width, and then set some new float point value, so 5.5 or something. And there we go. Now we change the render rect of any enemy via this function call. And that's how that component would work. Is there anything else I need to do for that? Components are usually pretty easy as long as you decouple them like this. Definitely not going to be const. The position value does need to be different than the render rectangle for what I hope are obvious reasons. Basically, you could be in a position where the rendered thing on the screen is not actually the position of the object for whatever reason, right? So you could have your button over here, but the actual clicky part is over here. It's just the rendered rectangle is over there. Does that make sense? It's good to decouple it, I think. But most of the time, yes, it is going to be set, you know, render box X and Y value to position X and Y value. It's should? Oh, I guess not, because the position usually is in the middle of the object, whereas the render box has the X and Y value in the top left of the box. Okay. I understand a little more now. Okay, so we have our position value, our render box value. What else are we making here? Let's do class. I guess I could just stick with that for now. That's not that bad. Nah, let's do a couple more. Why not? We have our position, render box. What else are we gonna need immediately? Collision box? That's gonna be super important in a rhythm game because, you know, timing is everything. Okay, so our collision box is also going to be an SDL frect. But it's going to be different than the rendered box, all right? Remember, we're trying to decouple as much as we can. So a position might be over here, the rendered image might be over here, and the actual collider part might be over here. And that sounds stupid, but what if you're talking like you're playing a video game with a spaceship? So the main part of the spaceship might be in the center, the hitbox might be the wings, and the graphic is the whole thing, which might look a little different where the position is, right? So that matters. The position might also be where the ship rotates on an axis if you're looking at it from top down in 2D space. Like the position might be in the back because that feels the best as a player, so you rotate on your tail, or it could be in the front and you could rotate like this. It just kind of depends on the game. But point is different from render box, is different from collision boxes, potentially. So that's kind of what I'm thinking by decoupling so many of them, you know? Sorry, I'm getting nasally. I'm gonna drink some water. 5 pounds of goddamn watermelon. Jesus. Okay, so we have an SDL frect. This is gonna be our collision rect. Now this is largely gonna have the same values. It just needs to be different values. Paste, 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 paste. Is there anything else we need to add here? I think this is about right. It's just important that this floating rectangle be a different floating rectangle than the rendered box, which is different from this. Although, don't I have an SDL F point? Don't I have like a SDL F point position? I should just call this pause. Let's do that. SDL F point return position. This is better. Then we're gonna set value. Delete that. Delete that. We're gonna set value to SDL F point. Oh, I should say, hold on. I should not do that. I should keep this X. Just this is position.x and position.y. And this should be a float value. I don't need to pass these by reference. They're just float values. It's what, 8 bytes? Yeah, we'll be fine. Okay, let's run, make sure we don't have any issues. Beautiful. Oh, that beautiful, ugly purple. Okay. So we have our basic components here. We should set up an entity factory right now, but I don't have much more time. All right, here's what we're gonna do. Tomorrow, we are going to set up what's called an entity factory. So rather than going through and being like class, object, musical note, class, object, hit points, or whatever, right? We're not gonna do any of that. We're gonna have a factory that will make entities for us and handle deleting them at the end of the frame, handle creation of them. It's gonna do all of that to make the actual designing of the game easier because, spoiler alert, I wanna make a level editor. I don't wanna program the levels. Fuck that. So that's the goal. We're gonna need an entity factory in order to do that easily. And we're gonna make an entity factory that will handle all of this handling of values and all that. So it's gonna be beautiful. Everybody, have a good night. I hope I just saved that. Have a good night. Have a good evening. I'm gonna have some more watermelon. And I'll see you tomorrow. And I'm gonna be shaved. Oh, big hype. Oh.